Alright, so this is your awesome tutor's video on complex or imaginary numbers. Now, what are these numbers, and how do you do math with them? Well, we're about to find out. Imaginary numbers use the letter I, kind of self-explanatory. Now, this is kind of the basics of imaginary numbers and how they work right here. I equals the square root of -1. That's what all this is based off of right there. So I squared equals 1. This is so because if you were to take I and square it, which means to multiply I times I, which is really just the square root of -1 times the square root of -1. And when you multiply two radicals, you can keep them under the radical, like as one number. So -1 times -1 is 1, and so the square root of 1 is 1. So that's the basics. Let's start off with some simple imaginary number problems. Now, we all know how to do simple square roots, such as the square root of 4, the square root of 9, obviously those equal 2 and 3. But what do we do if it was the square root of -4 or the square root of -9? Basically, all you really need to do is take out the negative, which you can do by replacing the negatives sort of with an I. So if we look at this first one here, and you can do this for all of these, is when you have like the square root of -36, well, we know the square root of 36 is 6. To get rid of the negative, we can take that out. The square root of -36 would be the same thing as saying the square root of -1 times the square root of 36. And we know the square root of -1 is I, and the square root of 36 is 6, so we can just combine those and we get 6i, which would be your answer. And you can do the same for the rest of these. Square root of 64 would be 8i. Square root of -17, well, can't really do that in your head without a calculator, but you could just say I times the square root of 17, that'd be appropriate. And then the square root of -18 isn't a perfect square root, but you can simplify it to 3i square root of 2. Now, besides simple negative square roots, you can also use these rules to help you with the addition, subtraction, multiplication, and division of imaginary numbers. Addition is pretty simple. You would use the same type of rules you would if you were adding variables together like x or y. So basically, you just add like terms, and like terms just have the same form, like whether it's a number or like a number with I on it. So either numbers are imaginary, and then they have to have the same exponent. And in these cases, all the ones you'll be adding will be to the first power. So for some examples, we'll take 3i plus 7i. They're both in the same like terms, you could say. So you just add the 3 and the 7 and you get 10i. For the second one, 23i plus 56i, in the same way. You'd add 23 and 56, you get 79i. And then for number 3, is a little different. You always have to be aware what's in between the parentheses. In this case, there's an addition sign. If there wasn't addition or subtraction, it would be multiplication. We'll get to that in a little bit. But in this case, it's addition, so you have to add the like terms, which in this case, 4 and 2 are like terms, so that's 6. And then 9i and 3i are like terms, so that's 12i. So you'll get 6 plus 12i. Imaginary numbers subtraction is basically the same as addition, except for you're subtracting. So same thing, you need like terms, and instead of addition, you're subtracting. So the first one, 9i minus 4i, would be 5i. And then the next two, you got to make sure they're like terms. So for number 2, you got 4 minus 2 would be 2, and then 3i minus 9i would be -6, so you get 2 minus 6i. And then for 3, I have my little reminder at the bottom that you have to remember to apply subtraction to all the factors. So in number 3, it's -2 minus 7i. So one way you can do it is you can change the subtraction to addition and then change all the signs in what you're subtracting. So I'd say 5 plus 5i plus negative 2 plus 7i. And so when you do that, you would get 3 plus 12i, which would be the same as if I were to say 5 minus 2 is 3, and 5i minus negative 7i, which is really 5i plus 7i, is 12i. So then again, you get 3 plus 12i. Alright, on to imaginary numbers multiplication. So for multiplying imaginary numbers, you will typically use the distributive property, just like if you were for normal numbers. And when you multiply and get I squared, this basically will just change the sign of its coefficients. So like you see on your screen, 24i, or 6i times 4i, which equals 24i squared, is the same thing as negative 24, because 24i squared is the same thing as saying 24 times negative 1, because I squared is negative 1. So therefore you get negative 24. So that'd be a simple multiplication problem. And then you have ones where you actually have to use the distributive property. Here I just have used A, B, C, D just to kind of show you how it works if you want to pause and look at that. If not, we'll go on to an example. So here we have 3 plus 6i times 2 plus 5i. So here you're going to use the distributive property. So you'll first multiply 3 times 2, which is 6. And then you multiply 3 times 5i, which is 15i. Then 6i times 2, which is 12i. And then 6i plus 5i, which is 30i squared. And so you get that. And then from there, you can combine the 12i and the 15i. And you can also combine the 6 and the 30i squared, because I squared is like saying negative 1, and 30 times negative 1 is negative 30. So when you do that out, you'll get 6 minus 30, 6 minus 30 plus 27i, which ends up being negative 24 plus 27i. And now we will move on to the division of imaginary numbers. So, like radicals, you do not want imaginary numbers in the denominator. So to get rid of this imaginary number in the denominator, you multiply the numerator and the denominator by the conjugate of the denominator over itself, which is really just 1. So multiplying by 1 really doesn't change anything. So this will cancel out the I on the bottom. So the conjugate is really just the change in sign. So if you had C plus DI, as seen at the bottom of the screen, the conjugate would just be C minus DI. So as well, like the conjugate of 3 plus 9i is 3 minus 9i. So if you want to take a look at what's going on, again, I just used some variables to just help you see a visual. And now we'll move on to an example. So, like, division is basically just two multiplication problems, because when you just multiplying the top and the bottom by the conjugate of the denominator. So you're going to multiply the numerator and the denominator by the conjugate. So in this case, you have 7 plus 2i over 5 plus 3i, so you multiply the numerator by 5 minus 3i and the denominator by 5 minus 3i. And from there, you just do multiplication and sum them all up. So I can just have you take a look at this work. If you understood the multiplication section, you should understand what's going on here. But basically, when you multiply the two denominators, in this case, you get positive 15i and negative 15i, which will just cancel out, and you're left with 25 minus 9i squared, and 9i squared is just negative 9, and so 25 minus negative 9 in this case is 34. And then for the top, you would just do like a multiplication problem. And when you do it all out, you'll get 41 minus 11i all over 36. Here I'll just give you some examples. If you'd like to do them, you can pause the video, write them down, work them out, and then I'll have the answers and the work shown for you so you can know whether you did them right or not. Here I'll give you the answers for 1 through 3. They are 10i, 10 plus 5i, and negative 3 minus 2i. And then the answers for 4 and 5. For 4, it is 78 minus 39i, and 5 is negative 9 plus 48i all over 53. Thanks for watching my video. If you have any questions, please comment or message me because I'd love to answer them. And I'll have more videos coming out soon. If you want any topics for me to cover or make a video about, please tell me. Please subscribe if you like my video and give me some feedback so I can improve on my future videos. Alright, have a great day.